Hello, I'm Samuel McDermott and I'm a postdoctoral researcher here in the Department of Physics at Cambridge University. My project is called autohaem and my aim is to make access to automated blood smearing more equitable through open source hardware. I have been working on the OpenFlexure project for the last 3 years. We have successfully developed open source, low-cost microscopes for automating the diagnosis of malaria. With diagnosing most blood-borne diseases, blood smears are essential and often the gold standard for the diagnostic procedure. However, whilst working with samples from the field, I found a pattern of systematic failure. A considerable number of the smears we were imaging were poor quality. The blood smears were too thick or poorly stained or had other inconsistencies. I wondered whether this was a localized issue or one that was a more common occurrence. From conversations with technicians around the world as part of the GCRF-funded Open DIDA network, I found this was a widespread issue that is global in scale and not just one related to malaria. Malaria is still one of the world's largest killers, yet many technological developments have not manifested themselves in the diagnosis of malaria, especially in developing countries. A key bottleneck that I will tackle is also the most inefficient process in the entire diagnostic procedure: blood smearing. Commercial blood smearing devices do exist, but they aren't accessible to the developing countries where they are needed. They are prohibitively expensive, easily reaching thousands of dollars, and their closed source nature means that servicing and maintenance becomes impossible. They also tend to rely on single-use plastics, making the devices unsustainable and short-lived in resource-constrained settings. What can address all issues aforementioned is open source, low-cost devices. For the past year I've been developing autohaem devices. These devices are 3D printed, low cost, and most importantly open source. They enable non-experts to produce blood smears as well as experts. I have tested them in our laboratory environment, and now the next stage is to spread the word, ask people in our network to build and test them, and start forming a feedback loop between the users and the designers. Openness will be core to autohaem's success. All of our 3D models, assembly instructions and software is available right now for download. This enables all scientists around the world to make their own autohaem devices and to improve and automate their workflow. I place special emphasis on our designs being easy to manufacture and assemble. The 3D models are designed to be able to be printed easily on the simplest of 3D printers, and the hardware chosen to be as accessible as possible. Crucially for open source hardware, the assembly instructions are clear and detailed, enabling exact replication. Our open source smear analysis pipeline builds on other open source software tools to provide a quantitative measure of the performance of humans and our machines at preparing blood smears.